Are you at a loss for how to do your technical interview?
Please help me.
Well, don't you worry. This video will guide you through that. As you may know, in the tech industry, you will be asked to do a technical interview where you code a problem on the spot. Tech companies will focus on this aspect the most, and the behavioral part of the interview matters, but not nearly as much as the technical portion. So, how do you prepare? Ideally, long before the interview, you want to study out of the Holy Grail, cracking the coding interview. I recommend that if you plan on going into the tech industry and you are a sophomore or above, just buy one now and look at the timeline. Sophomores can get internships too. This is very possible, so you will want to be prepared. A lot of technical interviews will be on the whiteboard, so practice on a whiteboard instead of just a computer. Now, we will show you a sample technical interview. All right, Robin, thanks for coming in today to interview with Nashia Inc. So are you ready for your interview question?
Yeah, let's get started.
All right, so here's your question. How would you design a stack which, in addition to push and pop, has a function min, which returns the minimum element?
Okay, well, thank you for the question. Just one quick question. What's the stack again? Awesome. So, I think the first thing that kind of pops into mind is that can we, for the sake of the interview right now, can we assume that the stack only has int type as an element?
Yeah, sure.
Okay, got it. So it's a stack of int. And do you have any preference on, the runtime of min? Because I can think of many other ways that we can code min.
It should be constant time.
Okay, that's interesting. Yeah, so do you have any example that you want me to run through, or do you want me to come up with my own example?
So this is a basic question, but if your stack is 7365, it should be returning 3.
Okay, right, because three is the minimum.
Yeah.
Okay, so if I want to make this example a little more specific, I want to have a stack there, and I would probably push 7, and this is the order that it's going to be pushed.
Yeah.
In, okay, 3 and 6 and 5. So somehow you want me to return the minimum element of 3.
Yes,
okay.
At constant time.
That's cool. So really, the first thing that comes into mind is brute forcing, but you said constant of 1 time, so I can't really pop everything out and then push it back in to check the minimum. So the way I was thinking was maybe if I create a local variable, let's say int min, and then as you're pushing it in, this value is getting updated after checking. So for example, when there's only one element in the stack, which is 7, int min will be 7, right? And then if 3 comes in, this is going to get changed to 3 because 3 is less than 7. And 6 and 5, although they're being pushed in, since they're bigger than 3, this is not going to be changing. So if you call min function, it's just going to return the value of int min.
All right, great. That sounds like a pretty solid idea. So can you add another element to the stack, 2?
Okay. So if I add 2, 2 is less than 3, so it's going to change the value to 2.
All right, so can you pop off 2 now?
Okay.
And what is your minimum?
That's a good question. Oh yeah, I guess the one downside of local variable is it's not going to keep track of the history of minimal elements. So, one downside of having local variable is that we have to keep track. It cannot keep track of history of min values. So if we can have another data structure, like let's say an array, and then as we are pushing in the element, we always keep this array sorted. We can actually retrieve min element with constant time.
All right, so what is the total runtime of this?
It's a good question. So, you know, sorting usually takes O of n log n, right?
Mm-hmm.
And then you will be sorting every single time when an element is either added or popped. So you would have n times n log n, right?
Mm-hmm.
As an overhead, and then retrieve would be of 1. So runtime actually would be n squared log n.
All right, so could you make it more efficient, even though we know that the actually getting the minimum is constant?
That's a good question. So, yeah, I mean, when I think about it, really the sorting part here, that's the bottleneck. So I'm trying to think if we can have another data structure so that we don't have to sort it every single time. And I'm leaning towards making an additional stack variable.
Great. How would you use this additional stack?
So I would have an additional stack, right?
Mm-hmm.
So when I push 7 in, 7 is the minimum
Yes.
inside of here, right? So I would have, 7. So this is keeping track of mins. And then if I push 3 in, 3 is the minimum, right?
Mm-hmm.
And if I push 6 in, well, 6 is not less than 3. So I don't think I should put in this stack, because I guess the purpose of this stack is when you pop it or peak it, it's going to be always the maximum or minimum element. So same with the 5, and then now if I add 2, right, and then there's going to be 2 here because 2 is less than 3. So if I call min, then it's going to peak the min stack and return 2, and that's actually also of 1 time or constant time.
All right, that's great, Robin. Are there any more optimizations you can do?
That's a good question. No, I don't think so, because this is kind of having an additional memory space, but then you would always have constant time. So in terms of time-wise, I think this is the most optimal solution that I can think of as of now.